All right, cool. So let's jump in. This is our agenda for the session. It's largely, I think, from this session and future sessions is largely discussion based. That's why we're here, in my opinion, at least. But I will spend a few minutes reviewing some of the key concepts that I took away from the this week's material. This is all background. You've all made it here, so you know the time. This is where we are in the course. This conversation is going to be focused on week 2 of the first course or module, and the main focus here is data ingestion. We've been spending a few minutes as folks have been arriving, kind of checking in on where folks are. Anyone else want to chime in on kind of general thoughts, or is anyone, is everyone largely kind of caught up? Or is anyone not caught up?
More or less caught up.
Cool.
Yep, caught up.
Yep, obviously the week 2 schedule.
Awesome. Yeah, I think, for this course, unlike some other courses that I've done, like the pacing seems to be pretty reasonable. Now, maybe that, changes as we get into some of the more advanced courses, but for now, for me at least, the pacing seems quite manageable. So the learning objectives for week 2 of the first module are to articulate the use case for sparse matrices as a target destination for data ingestion, explain the purpose of testing in data ingestion, know the initial steps that can be taken towards automating data ingestion pipelines, a little bit of discussion around data science versus data engineering and what that all means, and again, more kind of fundamental basics of data ingestion. So some of the key concepts that I picked out here were data ingestion overall. There was some conversation around ETL, and then the other stuff that I mentioned in the learning objectives. In terms of data ingestion itself, there's a lot of conversation in the course talking about kind of defining data ingestion and then comparing, contrasting it with ETL. I'll talk about the ETL part in the next slide, but the overall, I think the use of data ingestion here is fairly broad and tries to encompass extracting data, ensuring the quality of the data, and loading the data to the target destination or getting it into whatever target format that you're going to use for your exploratory analysis as well as your model building. I really like the quote, make it work, then make it better. Just along the lines of starting simple and then kind of building up as you go along. And I thought the first case study was a pretty good example of some of these principles. In terms of ETL, I'm not really sure why there was such an emphasis on ETL. I guess ETL, they both, I guess the use of ETL in the course to me seemed a little contradictory. They talked about kind of the importance of ETL, but then they talked about it like it was, something that was going away or kind of legacy. And I think the way I kind of parsed it all out is that, ETL, I think in many enterprises is kind of alive and well and still used as a way to pull data into kind of formal enterprise data warehouses. But more recently, I think folks have shifted to more newer types of data stores like data lakes, which are kind of the key distinction between a data warehouse and a data lake is that in a data warehouse, you have to define your schema in advance, and anything you pull into the data warehouse, you have to transform it into that schema. Whereas in a data lake, you're collecting the information, but you allow it to stay in its natural form, so you don't have to kind of normalize everything as it's coming in. And so the focus has shifted from ETL to what some people call ELT, extract, load, and transform. So you're getting the data from where it is, you're loading it into the data lake, and then you transform it when you need to use it to the format that makes sense for your analysis. And again, I think in the course, they use data ingestion broadly to cover, all of these different alternatives, with the emphasis being on, to the degree possible, using data in place as opposed to kind of moving it around preemptively. Anyone have any takes on the kind of ETL and data ingestion aspects of the course, or experiences that, how this shows up for you in your work that you might share?
Yeah, so hey Sam, hey everyone.
Hey Pedro.
I guess the way I saw, I'm sorry if it's a little echoey. I'm in an empty room. So the way I saw the reason why they introduced ETL so much and then gave up on it.
You got that impression as well, right? Oh, I lost your audio. Anyone else?
What was that key impression?
Pedro, I think we lost your audio. The impression that the way Pedro put it was they introduced the concept of ETL and gave up on it. And I think we had similar impressions of the way that they talked about ETL in the course. I think we lost Pedro. Oh, you're back.
Yeah, okay, sorry. So the way I saw it is that they kind of try to maybe reach people that are still in the not so much data phase, that are still using this more common, let's put it that way, ETL framework, and then try to convince you that for more enterprise and more large data sets, that doesn't quite work, and then convince you to use this new way of thinking about data lakes and data warehouses and the new stuff. So that was my only guess as to why they explained so much about it, to then just dismiss it as you said, as a legacy practice.
Mm-hmm. Yeah, I think adding to the confusion here is that I think the terminology is used to mean variable things and to mean different things in different places. So a lot of tech companies will talk about their data warehouse, but it looks nothing like the traditional enterprise data warehouse that you might see in a large legacy company. It's not like some star configuration thing. It's, maybe a bunch of files in S3, but it's what they call their data warehouse. And they might even talk about ETL as the process for getting stuff there, but it doesn't look anything like, a legacy Informatica pipeline or something like that. Any other thoughts or questions on the data ingest ETL stuff?
Yeah, so just my thought, and this is strictly the world as I see it, not part of any particular canon, or it is, we talk a lot about ETLs and very professional IT environment. Everyone talks about ETL, ELT, and so on and so forth. But when you work with startups and you work with data scientists and data engineers sort of all blended together, they don't force themselves into these specific role boxes. They have to do it all, including the feature engineering and so on. And I found that those folks who use R, they gravitate much more readily towards the idea of feature engineering using statistical methods and so on and so forth. The stuff that Max Kuhn talks about. I'll only bring up Max Kuhn because he's going to be here in Miami talking in just a few days. Anyone else think that way, that it's this idea of data ingestion should also incorporate the thinking behind feature engineering? There's Max Kuhn has a whole book on applied predictive modeling and feature engineering.
Well, that is an interesting segue to the next slide that I had here, which kind of gets at, I think, similar issues. They also spend quite a bit of time in the course talking about data science, and/or data engineering, and the varying roles of those two terms. And I think they were kind of echoing your perspective on this, that data science, even when you're in an organization that has data engineers, because of the iterative nature of building models, and because you're not going to necessarily spin up a data engineering effort at the exploratory part of a project, data scientists, and I imagine they would say whether they use R or Python or any other technology stack, need to be familiar with interacting with data sources. And where data engineers tend to come in when they're available is helping to harden and productionalize the data ingestion pipeline. But this, like the previous terminology discussion, this also varies widely from company to company, and you'll have a lot of folks that talk about their data scientists are full stack, quote unquote, full stack data scientists, meaning they're intended to be able to do data engineering tasks, the modeling, as well as the deployment types of tasks, which have more recently come to be associated with machine learning engineers in many organizations.
Exactly. Mm-hmm.
Any other thoughts on this stuff? In your various organizations, are you seeing all of these different roles, or how are things organized, where you work or in the organizations that you work with?
I've mostly worked in startups for the past few years, and as was said earlier, I think for us it's very much data engineers, data scientists are all sort of the same role.
Yeah.
Fluid that way.
Cool. So the next chunk of discussion in the course was focused on the idea of sparse matrices. Sparse matrix being one in which most of the elements are zero. I think the kind of the natural areas that you tend to find them are in various NLP tasks like TF-IDF, or one-hot encoding, or user term matrices for recommendation systems, things like that. But the idea presented in the course is that you can use sparse matrices, particularly during kind of dev tests early in a model lifecycle as an alternative to building out a kind of more robust data pipeline. So they kind of positioned it as a middle ground between quote unquote comprehensive data warehouse with extensive test coverage and a collection of text files, with the advantages being that they require less memory to work with than traditional or than dense matrices, and can be faster to work with in SciPy, for example. Now, this was presented, but it wasn't really, supported or used at all in the case study. And so I'm hoping that, we get some more time to kind of explore these ideas in practice in future modules or case studies. But it was, I thought it was interesting, interesting that they introduced the idea and spent so much time on it here. Does anyone have any experience working with sparse matrices in this particular kind of way, as kind of a data scratch pad, I guess, in a sense? No takers on that one?
Yeah, I hope we actually get to use them like in a meaningful way in the next modules, because as you said, the only thing they did with them was transform one to the other, from the CSC to COOs and everything.
Yeah.
In the notebooks that we'll probably talk about a little bit later, they don't quite get to them yet on the notebook of the study case. So as I haven't seen the other notebooks yet, I hope actually that we get to use them more.
Yeah, I'll dig into whether and where they come up later in the course, and if not, maybe we'll try to find some, examples or kind of supplementary projects or something to play around with, and we'll share whatever I come up with. I did include here a little bit of a cheat sheet on the sparse matrix formats. There are basically, there are actually several in SciPy beyond the ones that were mentioned in the course. The ones in the course were coordinate format sparse matrices, where the storage format is basically identifying the coordinates of the non-zero elements of the matrix and making up the storage format in that way. CSC, which is compressed sparse column, which removes redundancy in the columns, and CSR, which is the row-based analog. And then we talked about a bunch of the transformation methods, 2 COO, 2 CSC, 2 CSR, and 2 dense, which allows you to go from any of these back to a standard dense format matrix. There's also some examples of using, I think VStack was the one that was used in the example, but VStack and HStack are basically how you append or stack these sparse matrices vertically and horizontally, and then save NPZ and load NPZ are the way that you save and load them. And then there was, I think, emphasis placed on the fact that, like in SciPy at least, you can, like the train test split functions and other functions in SciPy are kind of sparse matrix aware, so you don't have to shuttle back and forth between the different formats, sparse and dense, in order to use them. But not all of the, not all SciPy functionality is sparse matrix aware. So you have to be a little careful of that. So the next thing that was mentioned in the course is data testing. Data testing is important as kind of a quality or sanity check for your data to avoid kind of a garbage in, garbage out kind of scenario. We spent a little bit of time or explored this, I think in some pretty rudimentary ways in the case study by testing for duplicate customer IDs and testing for missing stream IDs and things like that. What I think was missing in this discussion that I hope comes up later is kind of more, actually I'm pretty sure it's in one of the, there's a module that talks about unit testing for data, if I remember correctly, but kind of more of a framework-oriented approach for data testing. It's something that in my experience is immature. Folks tend to kind of roll their own. And I've talked to a bunch of folks, or not a bunch, several folks that are in like stealth mode, trying to come up with unit testing for data offerings or startups. I know of at least a couple of groups working on this, but there's not, I haven't seen a ton out there. I did come across an interesting thread on unit testing for SQL that I posted in the Slack, which kind of explored, why it's harder than traditional unit testing for code, but why you should spend some time thinking about it. I definitely recommend taking a look at that thread if this topic is of interest. Anyone see anything interesting out there in terms of testing, or have any approaches to testing that have worked for them that they'd like to share? I suspect a lot of people are doing it kind of like we do it in the case study, where you're just kind of ad hoc, throwing in tests as you're ingesting your data, and maybe putting those in a separate separate class or function, and flagging errors, or just doing I thought one thing I thought was interesting in the case study is, for example, in the duplicate customer IDs, we're just dropping the duplicates, as opposed to really spending time what's causing the duplicates, or which of those need to be kept if the data is different, that kind of thing. I imagine in a lot of cases you'd want to spend a lot more time with that and build something that's more robust. I think the bulk of the case study is focused on really starting to wrap your head around the automation of data ingestion pipelines. And there wasn't actually a lot of discussion of it, but it was kind of the core focus of it's a core focus of the entire sequence. And setting the groundwork for this was the focus of the case study. Beyond the course, there is a ton of work happening in this space. And I think things range in complexity from, getting your data ingestion code out of notebook cells and into some kind of executable file, whether that's through the approach we took in the case study, just copying those cells over, or tools like Netflix's Papermill, which provide or basically allow you to execute notebooks, like give you tools to make notebooks more of a kind of a first class executable citizen, if that makes sense. To more built out frameworks like this one, cookie cutter data science. Basically, it is a kind of, you can think of it as a template Python package or a templated Python project for data science projects that allows you to put your ingestion code in one place and your testing code in another place and your model development code in another place. And it's got a standard way of, standard directory structures and things like that to allow you to kind of, start with more structured approach from the beginning. Two, as you increase in complexity, there are a bunch of tools out there that folks are using based on directed acyclic graphs. Basically, each of the nodes in a graph is a processing step in your data ingestion pipeline. And once you construct this graph, then you can run it in some kind of graph runner, whether it's Apache Airflow or Luigi or something else. And these have the advantage of being able to automatically, because it's a directed acyclic graph, they can automatically determine dependencies between steps and enable things like parallelism, and some of the tools out there will kind of automatically checkpoint or snapshot your data from one step to the next, so you have kind of this robust ability to look at the data as it's being transformed and kind of roll back, for lack of a better word, to a specific stage in the process to see how the data is being manipulated. I wanted to plug my ebook on this topic if it's something that you're interested in looking at, in particular the kind of thinking about the broad landscape of tools that are used in this space. That is available for download on the TWIML website at this twimlai.com/AI platforms.
Thank you. Your ebook's a great resource.
Awesome. Thank you. Any thoughts on the automation of data ingestion pipelines, or comments on what you are working on in your work, or what you've seen other folks do?
I'm curious to see how the course is going to handle the fact that basically the more advanced and sophisticated your product or service is, the more specific platforms you need to choose. So we're going to use a case study, of course, but I wonder how generalizable this case study is. Specifically, one example is are the space matrices themselves, that they have, as you said, the SciPy module has some methods and some functions that are aware of sparse matrices, and they can, the NumPy library has this way of serializing and saving to disk some files. But when I see that, well, I first need to know how my product is going to behave in the future before I do some programming or start writing code that uses those kinds of matrices, because maybe someday I want to do something using the package that doesn't allow for sparse matrices to be used, and then I have a problem. So and still I thought they were kind of something that should be implemented behind the curtains, so something that should be programmed deeply inside the libraries for optimization, to optimize the code, and then and maybe something not that the user should have to directly implement.
because of this danger, let's put it this way, of having to change everything in the future just because you have like a pivoting moment in your deployment or anything,
Mm-hmm.
and then you have to roll back everything and rewrite code or anything. And also the fact that as I saw it, I don't know if there's any different use for this, but the serializing of objects to save them on disk, I couldn't find in the documentation any different thing that should allow me not to use a pickle, for example. So I couldn't find a reason not to use pickle. For instance, if I've been using it for any other kind of file that I've been saving or object that I've been saving, and to use NumPy's object saving capabilities instead. So I'm kind of curious to see how the course is going to address this. I mean, some of these features seem like very, very, very specific to very specific use cases. And I wonder if during the course we're going to be able to grasp what can be generalized and used in any case, or at least a framework of working.
Mm-hmm. Yeah, that's a good point. I think for a lot of, your point about some of these things should be done under the covers. Like when I think about the work we've done with the Fast AI library and the Fast AI courses, at that level of abstraction, you do see a lot of kind of under the cover optimizations happening where, they'll make those decisions for you, whether to store something in a particular format versus another. Here, this is, I think it has a lot to do with it wasn't really contextualized in the course. So like we're at this very low level of like looking at these kind of matrix formats with only high level explanation, and we haven't gotten to, what are some of the specific use cases around which you might want to do that. But I think that the more broadly, kind of the trade-off that you kind of speak to, the, building something, specific versus and flexible versus kind of using something off the shelf that, may, you may kind of run out of runway with because it's not flexible enough, I think is something that, we all probably have to always battle with. And sometimes you make the wrong choices and you have to rip something out and go, build out something, more custom or at a kind of using lower level tools than you might otherwise wanted to. Right?
Yeah, that makes sense.
Cool. So that's all I really had in terms of the kind of key concepts for the course. I had a couple of notes here on the case study really before opening up to kind of broad discussion around the case study. One is that the zip files and the notebooks even were kind of wonky. The zip files, I forget what the specific issues were with the zip files. I think there were images missing and stuff like that, but those have been updated. There was also in the database, there was a missing field or column or something that some folks have reported. I had not run into that issue. But in any case, Ray has reported in the Coursera forums that the zip file has been updated to fix those issues. And then there was another issue for folks that were trying to use Watson Studio to do this. The Watson Studio, the notebook kind of made it seem like, so when you upload your zip file into Watson Studio, it creates these data assets for you and these notebooks for you. And the notebook kind of suggests that you should be able to like transparently access the data assets, that they're just files and the notebooks have access to them. But the reality in my experience is that the data assets, they're actually stored in object storage. So IBM Cloud Storage, it's kind of an S3 analog. And you actually have to use code to, and there may be another way that I haven't found, but in my experience, what I had to do is use code to basically copy the data assets out of that cloud storage into the local file system that the notebook is running in. And I posted about that in the Slack channel as well as over on Coursera. I know Vince ran into that. And Vince, if you have any problems getting that working, you just ping me on Slack. Anyone else run into either of these issues?
Yeah, when I downloaded it, my DB file was empty. Actually, the queries wouldn't return anything, and I tried downloading it again, and I couldn't really get a working file. So
Was that in Watson Studio?
Yes, I uploaded the zip file to Watson Studio I tried running it in my local Jupyter, and it didn't work, and I thought it was maybe something about Watson Studio itself that would make it work, and when I tried it, it didn't as well.
Here's what's happening there. When you run the SQLite Connect, if the database that you specify doesn't exist, it creates it. So basically, you can't access the database that you uploaded to your data assets. In your notebook, you tell the driver to connect to it. It creates an empty database file, and then you try to query it, and it has nothing in it. And so the trick is, see if I can, the trick is to basically copy over the files from the this data asset area into your local directory, like a data directory, and then you can just operate on them like normal. Does that make sense?
Yeah, it does. Thank you. Yeah, I hadn't thought of that.
Yeah, I was banging my head against this for a while, and a number of folks were banging their heads against it in the Coursera forums. And so I started clicking around, and like the first thing you need to do is here you insert this project token, which basically sets up a shim that allows you to, or context that allows you to access these files easily. And then I just copied them over. And then in some of the code down below, he was doing something with like streams or this code here. I never quite figured out what that was all about. Did anyone else? So those are the main issues. What experiences did you have with the case study? Tell us, what you learned, what you thought about the case study. Let's talk about any challenges that folks ran into. Did where can we get a sound off? Where are folks? Have most people tried it? Has anyone finished it? Where are you? I got mostly I'm mostly done, but my kind of the if you've gotten to the end of it or have at least read through it, one of the things you're trying to do is you build out this data ingestion function, and then you try to convert it so that it operates in batches, and then you compare the output of the kind of monolithic run and the output of the batch run and see if they're the same. And somehow mine aren't the same, and I haven't had a chance to figure it out what's missing yet. Where's everybody else?
Not as far as you are, speaking for myself. We pick up this this Q&A at the start of the next week session.
Say that again?
Can we pick up this Q&A at the start of next week's session?
Okay, so refresh on this this project at the start of next week. Sure. How about other folks?
Hey Sam, Shyam here. So I have been through most of the exercises. I am not using the Watson Studio. I'm doing it in my local Jupyter Lab machine. I have mostly done all of this except the last part where you divide it into different functionalities. So I have gone through the functionalities, I've implemented those. But after I went through the answers, there's an answer sheet at the end, right? So I found that the results are the same, but there are different methods to do that. For example, how do you find out who has not been subscribed and stuff? There are quite a lot of different options and which I didn't know about. So I go to learning experience, and right now I'm trying to benchmark like which is a better option, which would be a faster option, and what are the similarities and the differences that might be coming around. So that's what I'm doing right now.
Cool. That's probably the thing to do. I kind of looked at those and said, oh yeah, different strokes for different folks. But there are definitely lots of different ways to do it. My way, for example, of calculating the age was way more complicated than what they did in the answer sheet.
Yeah.
Cool. Who else wants to share their experiences with the project so far?
Well, I think for me, I'm pretty much in the same place you are, Sam. I finished, bringing it out of the notebook and running the file, but I haven't actually gotten my final answers to match yet. So just that test isn't done. And yeah, I think I found the answer key helpful in that the same. I sort of ended up noting like, okay, here's one way to do it. Here's another way to do it. And just kind of playing with both of them just to expand my knowledge. And I think otherwise I did find the answer key was, I wondered the error with the databases. The answer key had it was clearly written for a slightly different database. Like I think if I remember correctly, something like, I can't remember, one of the tables was combined with another or something. I don't know. But it was fine. I think figuring that out is good because it just forces me to make sure I really understand it, right? So, but yeah, no, I thought it was a good exercise, and I think if it's about this level of work every week, it's good. I think I find it manageable and learn, and I'm learning enough and find it manageable as well, which is good.
Cool.
Challenging enough, but also manageable.
Yeah. I'm a little, I haven't dug into either my results or their results for the batching part of it, but when I think about that, like the streams file, the streams file has a bunch of basically customer IDs and stream IDs, and if you kind of randomly split the streams file someplace, then, you know, some of your customer IDs could be in one file, and some of your, or you could have duplicate streams for a given customer in the two files. And so it seems to me like you have to do more kind of accounting in order to merge those two output files than what I saw in the solution. So I don't know, that's kind of what's next for me, is to really dig into that and figure out, you know, either what he's doing that wasn't obvious to me at first glance, or what, you know, what needs to happen to kind of reconcile these two files that, you know, that are supposed to be, you know, that are interdependent, I guess, is the main idea. Anybody notice that or run into that at all? It sounds like those of us that have gotten to that part have all kind of run into this issue of our files not matching, and maybe that's the root cause.
Well, I actually, to be honest, I have not found the time to just, like, I finished, got it working, and then I didn't have time to test it to make sure it matched. So maybe mine match. I don't know.
Okay.
But I haven't actually tested it
Fingers
yet.
crossed.
Yeah. And right now I'm calling from my phone because I actually had to take out, like, I had to leave home a little bit, so I'm no longer from my laptop to be able to check. But
Cool.
I know what they did in the answer key was they split it just in half, like, you know,
Yep.
just 0.5, and then I guess the way I handled it on my end is I actually wrote, like, when I put it all back together, I then did check to make sure that I had overwritten anything that previously existed, and then brought in everything that didn't, and then sent that to the CSV.
Okay.
So I was so I tried to account for that. So
Yeah.
no, I haven't tested it. I don't know if that works or not, but my hope is that it should be fine. But I don't know if anyone did it differently to account for that, or if there's a better way to do it.
Yeah. Well, we'll trade notes on that beginning of next time and see how far folks have gotten. Anyone else want to chime in on either the case study or anything else that they ran into or experienced with this week's content? Is there anything that anyone needs help with or didn't understand or could benefit from, you know, someone explaining?
Yeah, I do actually. I could, especially after reading the notebook and the thread that you sent. I'm having a little bit of a difficulty grasping what's the actual practical difference between data testing and data wrangling, or actually quality assurance in data and data wrangling, because in the notebooks, I have it open here if I'm not mistaken, it assesses data quality, quality assurance, and what it says is checks for quality assurance, like removing repeat customers based on customer ID, and removing data that has no stream ID. But how is that different from regular data wrangling, where you're trying to clean up your data and you're trying to, or is that actually the same thing and they're using different names? I don't know if I've made myself clear.
Yeah, no, I think that makes sense, and I think it kind of echoes the point that Mash, I think, brought up earlier, and that is that there's a lot of overlap here. I think the data testing, you know, can be considered part of data wrangling, perhaps. I think the main takeaway is that you have this continuum of activities, and in a lot of ways, each of the steps in the continuum is iterative. So you've got, and this came up in the Slack channel as well. You've got kind of this data ingestion phase where you're pulling data in, but you're also, you know, trying to test it and clean it and, doing some basic wrangling, and then you're going to move to a phase where you're trying to build out models, and you're going to do more wrangling, and you probably see things that, you may turn up things in the data that are, missing data, or, things that you hadn't thought to test before. And so you kind of go back to your ingestion pipeline and you add more tests. And so you could think of it all as data ingestion. You can think of it all as data wrangling. You're doing tests kind of along the way, so that, I think to me, the big kind of takeaway of this, the case study and this lesson is like, I experienced it going through the project. Like, you do all these things and you do kind of a lot of the exploratory stuff in notebooks. And, at least when I use a notebook, I'm testing stuff with cells, and I get cells all out of order. And, the notebook doesn't provide a as repeatable a way to kind of run your ingestion process / your wrangling process, until you do that very last step that we did in this project, which is kind of pull all your code together and kind of spit it out into a runnable file. Then that all the dependencies are there, you're importing everything you need to import, all your functions are there, and it's kind of isolated and repeatable. And then I think as we go deeper into the actual wrangling and model building, what I suspect is they're going to say, okay, you identified some missing data, now go all the way back to that ingestion file, and add the test, or add the the fix, the step that cleans it, as opposed to doing it later. It's TBD, and kind of, I think mileage will vary depending on the specific situation, but that's kind of, I think, what all this is foreshadowing. But long story short is, the terminology is kind of variable and a bit all over the map. Did that answer your question?
Yeah, I did. I mean, that's
Not a satisfying one, but
no. I mean, that's something we all, I guess, have to keep in mind, is that, especially as you mentioned yourself, that data testing is still a relatively new field. I don't know if I can put it that way, but which means that there's still everyone's still borrowing each other's terms and ways of explaining stuff, and just changing a word here or there in phrases we've been hearing for years now, and trying to put new meanings in things, and this can cause this kind of confusion, I guess. So I guess we'll just have to brace through it. So.
Cool. Maybe unless anyone has actually, let me just make sure. Does anyone have any other questions or things that they need help with or want us to chat about? If not, then before we wrap up, any comments about the format of the study group? How's this working for you? Is it helpful? Excuse me. Are there other things that I could be doing that would be helpful? What do you think about the study group format?
Yeah, for me,
I think it's
great.
It works.
Yeah, I think it's helpful. I think I don't know. I mean, I think I haven't used a Slack channel much. I know that maybe while I'm working on things, it might be useful to just reach out in addition to the group, or maybe. But I think the way you're doing it right now, Sam, I think it's helpful, and we'll see as the work probably gets a little bit harder and we do a little bit more. We'll see if there's any other thoughts I have, but I think right now it's helpful.
Cool. All right, well, if anyone has any ideas for things that we can do to improve it, definitely let me know. With that, congrats on completing course 1 or on soon completing course 1 if you've not quite finished. Next week, we'll move on to course 2, the first week of which focuses on data analysis and visualization. I'm around on Slack, and we've got 150 something other people that are there. If you run into any issues or want to share any of your observations in working through the course, and looking forward to chatting with you all next week.
Sounds good.
All righty. Bye-bye. Have a great weekend.
Bye, Sam. Thanks.
All right,
Bye,
thanks, Sam. Have a
Sam.
good one.
Thanks.
Bye.
Bye.